So the values which we have got to plot magnitude plot is when omega is equal to 0.1 we have got 40 dB, 2.5 12 dB, 10 minus 12 dB and 100 radians per second we have got minus 72 dB. So these values will be plotted. Along x-axis we'll be considering log of omega, and this log of omega will be considered as the first one whatever you see here, that will be considered as 0.1. Next second one, the line 2 whatever you see, that will be taken as 0.2. This will be 0.3, 0.4, 0.5, like that it will continue, and later we'll arrive at 10 to the power of 0 which is equal to 1. Next 2, 3, 4, 5, 6, 7, 8, 9, 10 to the power of 1 is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. So like that it will continue. So this is along x-axis. Along y-axis if we observe, we have to consider magnitude. So if we observe, the highest magnitude which we have got is plus 40 dB and the least magnitude which we have got here is minus 72 dB. So we have to accommodate all these things here. So if we have to accommodate that, so in our graph sheet, initially let us take 40 decibels, then 30, 20, 10, 0, minus 10, minus 20, like that. One division I have taken as 10 decibels, one unit I have taken as 10 decibels. Next, whatever values we have got, so based on those values we'll try to plot. If we observe at 0.1 radians per second, we have got the amplitude as 40 decibels. So this is 0.1 along x-axis which is omega, this is 40, so somewhere here we have 1 point. Next, when omega is equal to 2.5 radians per second, the amplitude which we have got is 12 decibels, 2.5. So 2.5 will be somewhere over here. This is 1, 10 to the power of 0, this is 1, 2, 3. So between 2 and 3, somewhere over here we'll be having 2.5, exactly between that. At 2.5 radians per second, the amplitude which we have got is 12. So this is 10. Along y-axis if we observe, one division, one unit is equal to 10 dB. So if we observe, we have 1, 2, 3, 4, 5 small lines here. So if one complete division is equal to 10 dB, one line indicates 10 divided by 5 which is 2 dB. This is 10, so this should definitely be equal to 12. So at 2.5 radians per second, we have to plot 12 dB. So this is 2.5, approximately this is 2.5. So somewhere over here we'll get 12 dB. 2.5, this will be 12 decibels. Mark a point there. Next, the third value which we have got is at omega is equal to 10 radians per second, the value which we have got is minus 12 dB. So that minus 12 dB should be plotted over here for omega is equal to 10. So we have omega is equal to 10 over here, this line. We have to plot minus 12 here. So this is minus 10, minus 12. This will be the point where we get minus 12. Minus 12, minus 14, minus 16, minus 18, minus 20, like that. So this is minus 12. So this minus 12 and this 10, wherever it coincides, there we have to mark a point. So this is the next point. And finally, when omega is equal to 100 radians per second, the value of amplitude which we have got is minus 72 decibels. So we have to plot that minus 72 for 100. This is the 100th line, minus 72. Where we get, this is minus 70. So the next line, the next small line, whatever we see is minus 72. So that is for 100 radians per second. So here, this is minus 72. So these are the points which we get in a magnitude plot. Always we have to remember one thing, when we are plotting magnitude plot, the 2 points which whatever we have got should be joined using scale. Don't use freehand sketch. Don't join using freehands. Always use scale. After this, we'll be writing the slope. This will be minus 20 decibels per decade. This will be minus 40 decibels per decade. And this will be minus 60 decibels per decade. So this is our magnitude plot. Now, after after magnitude plot, we have to find something called as gain crossover frequency. To find gain crossover frequency, we always consider 0 to be a reference line, 0 dB to be a reference line. So mark a horizontal line from 0 decibels, complete horizontal line you mark. So after marking horizontal line, check where this horizontal line, the reference line, 0 dB line, where it is exactly touching our magnitude plot. If we observe at this particular point, the magnitude plot as well as our 0 dB reference line is touching, and from there extend that particular line, extend that particular point along x-axis. So when we extend that particular point along x-axis, it will meet at certain frequency. So that frequency is called as gain crossover frequency. If we observe according to the graph which I have drawn, approximately the gain crossover frequency which I have got is 5 radians per second. So gain crossover frequency omega GC is equal to 5 radians per second.